for division properties of exponents, section 7.5. Follow along on your worksheet. Division property of exponents is based on this idea that if we have 2 to the 4th, we have 4 2's lined up on the top. 2 to the 3rd would be 3 2's multiplied together on the bottom. And we know that if we have a factor on the top that's the same as a factor on the bottom, those in fact will cancel out and it's just 1. So we see that 3 sets will cancel out, leaving me with 1 2 on the top, or 2 to the 1st power. With variables, it works the same. On the top, if we expanded this, we'd have 2 x's and 5 y's, and on the bottom, it would look like that. We could cancel out. 2 of the x's would cancel. And on the y's, 3 of them would cancel. What that leaves me left with is y squared x to the 4th over x to the 4th. Y squared is on the top, and the x to the 4th is on the bottom. So rather than having a rule, we're just going to forget about a rule. We're just going to cancel, and we're going to watch where we put our leftovers. Are they on the top or on the bottom? So for this next problem, I see on the top I've got x to the 8th, on the bottom x to the 3rd. I know that some of the x's will cancel, 3 in fact, so 3 will be gone. These 3 would be totally wiped out from the bottom. And then from these 8, 3 of them would cancel. So 8 cancel 3 would leave me with 5 left over. So my final answer would be x to the 5th over 2. 2 is still on the bottom, and it remains there. This next one, we have these numbers involved, 4 tenths, and we don't treat those any different than we have before. 4 tenths could reduce to 2 over 5, 2 fifths, but I'm going to just extend this fraction bar out a bit. My x's, I've got x to the 3rd, and on the bottom that's x to the 1st, so 1 would cancel. So this 1 would totally cancel out from the bottom. 1 would cancel from here, leaving me with x squared left on the top. On the y side of things, I've got y squared on the top and 8 on the bottom. There's more on the bottom, so 2 are going to cancel, just 2. So these 2 on the top would be gone. 2 would cancel from here, so from 8 cancel 2, would be 6 left over. So I got y to the 6th. And then the z doesn't cancel, doesn't move, it just hangs out on the bottom, remains there. In my next one, 15 over 5 reduces. 15 divided by 5 is 3. And that would be on the top of the fraction. You could think of it as 3 over 1. Canceling my variables here. M to the 4th, m to the 10th. 4 will cancel, so I'm going to cross out 4 of them. Cancel 4 from the 10 leaves me with 6. They are on the bottom. And then with my n's, I've got more of them on the top. So that's where my leftovers are going to be. 3 are going to cancel. These 3 would be gone. 4 canceling 3 out would leave me with 1 left over. And you don't need that exponent there. You could leave it off and it would still be correct. So let's look at a couple examples more that would apply this principle with maybe some others mixed in. So here we've got 2 fractions being multiplied together, and we know that when we multiply fractions, we multiply the numerators, the tops, multiply the denominators, the bottoms. So I just think of this as one large fraction. So I multiply the tops, a to the 8th, b to the 4th, over, multiply the bottoms. And when I do that, I'm going to put these a's together. I've got a to the 3rd, a to the 2nd. That gives me a to the 5th. Now that I've got everything put together, now I'm going to simplify. I'm going to cancel out. So a to the 5th and a to the 8th here, those ones. I'm gonna cancel out these 5. These were 3 left over on the top. The B's, 4 will cancel, so these 4 would be gone. 4 canceling from here would leave me with 3 left over. So what's left on the top? A to the 3rd. That's it. What's left on the bottom? Well, this canceled out. I'm left with B to the 3rd. Next example has a negative exponent, so things get a little messy. In this problem, there's a couple different ways that we could approach it, and we could still end up with the same answer. So I'll show you one of those ways. I'm going to first simplify what's inside of this parenthesis, and then apply the exponent here on this outside. So I'm going to simplify the m's first of all. 3 will cancel out. These 3 would be totally gone. 2 on the top left over. And then with the n's, 3 are going to cancel. 4 are left over on the bottom. Now I'll apply this exponent here. Both of these need to be squared, or raised to the negative 2nd power. So I get m to the negative 4 over n to the negative 8. Negative exponents are in our way. We need to flip them over the bar. Yeah, that's the way. So this negative exponent moves up to the top. This negative exponent moves down to the bottom. And finally, last one for our notes. We will first kind of deal with the numbers first, then combine our g's together. The h value, before I deal with anything, I need to deal with the fact that this is a negative. Negative exponents, okay, I don't want to deal with them in my problem, so I'm going to first bring this one down to the bottom. H to the 4th, so I'm going to kind of wipe it out from this top here. It's on the bottom now. So then I will also combine my h's together. So the number is 12 divided by 4 is 3. Again, it's on the top. 3 of the g's are going to cancel with 3 on the top, leaving me with 5 left over. Leftovers are going to be on the top. And then the h's are all on the bottom. I've got h to the 5th and h to the 4th. So it's 5 h's on the bottom here, 4 h's on the bottom here. Put those together, that's really 9 h's, about 9 factors of h multiplied together, h to the 9th.